Okay, hold your breath. We are live. Hey, what do you know? Okay, so today, 3:30, 2:21. So today's objective really has to do with logarithm rules. Logarithm rules, okay? So we have to know this. Logarithms are exponents. Logarithms are exponents. And I'm going to write this down. We know that if we have some base to an exponent equals an answer, we can change that to log base b of the answer equals, okay? And then the reason I'm putting that up there is because, I mean, to me it's obvious, but to you it's not. What are logarithms? They're exponents, aren't they? What are logarithms? Logarithms really are exponents. So when you do a logarithm, you're finding the exponent, right? So if logarithms are exponents, then they're going to follow all of the exponent rules, okay? So we know the product rule, okay? So example, if we had x to the third times x to the fourth, what do you do with the exponents? You add them. And that's the same thing on the product rule. So if you have a log, it's going to be the same base, log of base b, right, times a times b, okay? So it's a logarithm really of two bases. So, Ellie, you're right. So we can rewrite this as log. Oh, log, come on, I got the base already there. Sorry, my bad. I'm going to rewrite this as log base b of a plus log base b of b, okay? So if you've got a logarithm of two things being multiplied, they're exponents, okay? And they came, or you can go vice versa. If you're going to add two logarithms, you can bring together and multiply the bases. Quotient rule, same thing. So if I have x, say, to the fifth divided by x squared, how would you simplify these? What would you do to the exponents? You'd subtract them, wouldn't you? Right? You'd make it x to the third, you subtract them. So the quotient rule is the same way. So if log, I keep doing that. Why do I keep doing that? I get ahead of myself. If I have log base b of a divided by b. So if I have a log expression where I have two bases are being divided, then I can rewrite it as log base b of a subtract log base b of b, okay? So we'll see these. If you have two bases, two different logarithms that are being subtracted, we can bring them together and divide the bases, okay? Now the power rule. We have x to the, third to the fourth power, okay? So if we have an exponent to the exponent, right, the way we would simplify this is we multiply, right? We multiply. So we can do the same thing with logarithms, okay? So if we have an exponent to an exponent, so if I have log base b of, let's say, a to the p power, right? So in a sense, I think about this. This is an exponent. This is an exponent. It doesn't look like an exponent, but we know logarithms are exponent. We have an exponent to an exponent. We can multiply the exponent. So we can rewrite this as bring down the p, and we multiply it times the log base b of a, okay? Change of base rules. Now, I have a fancy calculator, and my fancy calculator can do any base. Not everybody has a fancy calculator. In fact, if you guys want to use your phone does not have a base changer. So what we can do is this. If we have log, let's see, base b of a, okay? And this is not base 10 or base e, okay? Right? So in my calculator, I've got log base 10, easy, right? I got log base e, easy. I can just touch my calculator. And you guys in your phones, I think you have both also. Let me double check. I'm pretty sure if you go to your phone, you go to, hold on, let me go to math school. Let's get my calculator. Turn it sideways. Come on, there you go. So you guys will see that in your phone you have log base 10. I think you have natural log. Well, you got E. Where's your ln? Oh, yeah, you got ln. So you've got these two bases, but you don't have any other base, okay? So in your phone, if you want to do logarithms on your phone, you can either use base 10 or base E. So if you don't have, say, base 5, what you do is this, and I'll show you an example. What you can do is you could rewrite as log of A divided by log of base B, okay? Example. Log base 5 of 125. I want to do an example real quickly because we did this, okay? I know the answer is 3. Okay, everybody okay if the answer is 3? We did this as our warm-up. So I can go to my fancy dancy calculator because I'm kind of special. I'm a calculator, whatever, Mr. Davies, right? And I can go straight to log base 5 of 125. Boom. But if you don't have a fancy dancy calculator, you can just go say, okay, well, I can just rewrite this as log of 125 over log 5. Now, when I write this, we'll get the same answer. When I write this, what's my invisible? I didn't write a base. What's my invisible base? What's my invisible base? Base 10, right? What's my invisible base? Base 10. So you can use an ordinary calculator to do this. In fact, I think your phone probably even works, but one phone. I could probably go clear. It's a little hard to do on your phone though. 125. If I go log divided by 5 log equals, I get 3. Okay, so you can do this. You can do this. Or on my big calculator, if I decide just to use log, but I go log 125 divided by log 3. Okay. Uh-oh. Well, that's because I went 3, not 5. Try again. Log 125 divided by log 5. Okay. So what I'm trying to say is if you don't have a calculator that will do any base, you can do any base by just taking the log of the answer divided by the log of the base. But when I'm doing this base 10, which your calculator has, okay? All right, now let's keep going. So example 1, expand. So if you take calculus, and I don't know if you will or not, but if you take calculus, this, believe it or not, is a really hard problem in calculus because you'd have to do something to the 2, then you have to do something to the x, something to the y, something to the exponent. When you take calculus, there's this thing called a derivative, and this thing's a pain, okay? But in calculus, they'll use the rule I'm going to show you. So they're going to expand it to make it easier, okay? So we're going to go log base 3, right, of 2. Now, it's 2 times x, isn't it? It's 2 times x. You guys agree it's 2x, 2 times x? So we get a rule. When we times them, we can separate them by plus. So I'm going to go plus log base 3 of x. So 2xy is 2 times x times y, but when we multiply 2 things, go up to our rule. What do? We add them. Plus log base 3 of y to the 4th, okay? So where I see multiply, this just this easy. When I see multiply, I separate or expand it by plus signs, okay? Now, there's one more thing I can do, and that is if I have a power, or an exponent, I can bring the power down. So I'm going to do one last thing. I'm going to take this 4 and float it down, because I've got an exponent to an exponent. So I'll finally rewrite this problem as log base 3 of 2 plus log base 3 of x plus 4 log base 3 of y, okay? So that's an expanded form. It's not that hard. Again, where you see multiply, we pull it apart. You take it apart when you see multiply with plus signs, okay? Thumbs up on that? Good. And when you see an exponent, you bring the exponent down in front, okay? That's what we do. Now, in number 2, I see a divide by. So I'll subtract, okay? Does that make sense? So I've got a log, natural log, okay? So I'm going to go and rewrite this as natural log 3 plus, because it's 3 times, right, plus natural log x squared. And then minus, I'm going to go subtract, because of that right there, I'm going to go subtract natural log of y. So where I see multiply, I change it to plus, and where I see divide, I change it to minus. Now the last thing I'm going to do, I have an exponent. So I have an exponent, I bring the exponent down in front, and it simplifies it significantly. This, if you take calculus and you do derivatives, this will really help a lot. Okay, so we get natural log of 3 plus 2 natural log of x minus natural log of y. And then in calculus, you can go, boom, that answer is going to be 3, that answer is going to be 2 over x, that answer is going to be a 1 over y. Okay, anyway, moving on. Now on number 3, we're going to do just the opposite. We're going to condense it to a single logarithm. So we're going to put it together as a single logarithm. So I'm going to go like this, single logarithm. So start off with log of, right? Single logarithm, right? There's no base, so we know the base is 10, okay? There's no base, so we know the base is 10, okay? So the first thing I'm going to do is this. These numbers were exponents. I'm going to bring them back inside. Okay, bring them back inside. So I would have really a x cubed, so I'll have a log x cubed plus a log y squared minus log z to the 5th. Okay, so I did is I brought my exponents, I brought this 3 back in. It did float down, but now we're going to float it back up. And then the last thing I'm going to do is, where it says plus, I'm going to make it multiply. Where it says subtract, I'm going to make it divide. So I'm going to rewrite this as x cubed times, I don't need the times sign, but I'm going to put it in there anyway, times y squared divided by z5, okay? We brought the exponents in first, brought the exponents back in, okay? And then if it says plus, it was multiply, and if it says subtract, it was divide, okay? How am I doing? Doing okay? It's kind of weird. These rules you won't really need until you get to calculus. Okay, turn the page. All right, now, example 4. Well, if you have a fancy density calculator, example 4 is really easy. It really is. So you really have log base 3 of 12, which is, in a sense, 3 to what power equals 12. That's what it says, okay? That's what this says, 3 to what power equals 12. And I'm just going to use my calculator. Okay, so I'm going to go, where do I find it? Guys, where do I find that special base? Come on, where do I find it? What button do I push? In the math, right? So go math. And you guys can use these calculus on the quiz on Friday. Of course you can. Log base 3 of 12, and I get an answer of 2.26. Approximately equals 2.26. That's my approximately equal, okay? Or if you don't have a fancy calculator, you just say, well, wait a minute, I don't have a fancy calculator, but I could just go log of 12 divided by log of 3. I could do it that way. And what's my base? It's base 10, which most calculators will do base 10. You can even do that on your phone if you had to, right? If you had to. Come on, turn for me. Come on, there it goes. So you could technically do this on your phone if you had to. Okay, clear. And I could go 12 log divided by 3 log equals, there it is, but 2.26. So you can do it on your phone, but it's kind of a pain doing it on your phone, isn't it? Okay, example 5. Well, I know 5 to the x equals 145. It's probably going to be 3 point something. 3 point something, probably 3 point something. I don't know what the something is, because I know 3 cubed is 125, right? So, guess and check. Are you kidding? No way. Let's change it to a log. So change to a log. All right, so we'll rewrite as a log. We'll go log base 5 of 140 equals my answer. So again, fancy dancy calculator. Lucky me, I have fancy dancy calculator. I'm just going to go my log, my math button. It's in my log. And I got it there. Log base 5 of 140. Whoops, 140. I get an answer of about 3.07. Okay, 3.07 approximately equal to. Or if you don't have a fancy button, you can just take it as the log of 140 divided by the log of 5. Then you can use a standard calculator or your phone, right? Okay, so clear. So if you have to use your phone, you can just take 140 log divided by 5 log equals, and there it is. Okay, so you can use your phone if you had to, okay? But you don't have a special base fancy button on your calculator, right? Okay, so today, homework, page 156. And we're going to do 1 through 17. Oh, it seems like a lot, but these aren't too bad, okay? And the extra is number 18. The extra is kind of hard, but that's okay. That's what the extras are for. And that's all I have. Let's see if it'll turn off for me. I wonder if I buy a new battery for it, if it works.